What happens when the most powerful naval formation on Earth fires its last interceptor? A U.S. carrier strike group can launch stealth fighters, command Aegis destroyers, track threats hundreds of miles away, and project American power across an entire ocean. But all of that power depends on one number: the number of missiles still left in its VLS cells. When that number reaches zero, the carrier does not have to be sunk to be defeated. It can still be floating, still moving, still carrying 5,000 sailors, and yet no longer able to fight its way through the next wave. And according to the Pentagon's own war games, this is not fantasy. It is a real vulnerability, because adversaries like China and Russia understand exactly how to exploit it. They do not need to destroy the carrier first. They need to drain the shield around it, send drones, add decoys, mix in cruise missiles, force the escorts to keep firing. Then, when the expensive interceptors are gone, the real danger begins. Welcome back to Future War Tech. In this episode, we are going to break down the nightmare math behind modern naval warfare. How many defensive missiles does a carrier strike group actually carry? How fast can a saturation attack burn through them? Why can't the F-35s solve the problem? And what happens in the Western Pacific if America runs out of missiles before the enemy runs out of targets? Stay with us to the end, because the next naval war may not be decided by who has the biggest ship. It may be decided by who still has missiles left when the final wave appears. Chapter 1. The Missile Countdown. Forget the recruiting commercials. If you want to understand the terrifying vulnerability of an American carrier strike group, you have to strip away the PR and look at the real inventory. At the center of the formation sits a 100,000-ton nuclear-powered supercarrier. She carries 75 aircraft, a lethal mix of F/A-18 Super Hornets, and a growing detachment of stealth F-35C Lightning IIs, backed by Hawkeye radar planes. Below the surface, running silent, is a Virginia-class attack submarine. And surrounding the carrier, drawing a perimeter of denied airspace, are the escorts, 3 to 4 surface combatants. Arleigh Burke-class destroyers carrying 96 Vertical Launching System (VLS) cells, and Ticonderoga-class cruisers packing 122. The terrifying arithmetic of modern naval warfare comes down entirely to those VLS cells. Add them up across a typical strike group, and you get somewhere between 300 and 400 steel silos. It sounds like an impenetrable fortress of firepower. It is not. Those cells are not all loaded with interceptors. They cannot be. Modern American destroyers are jacks of all trades. The Navy has to cram a diverse mix of weapons into that limited space. Tomahawk cruise missiles for offensive land strikes, vertical launch ASROCs for hunting submarines, and finally, the standard missile family to defend the skies. It is a zero-sum game. Every cell you give to offense is a cell you take from defense. In a realistic combat loadout, the Pentagon's own planners assume that fewer than 2/3 of those cells are dedicated to air defense. Open-source analysis, backed by recent congressional testimony, puts the actual count of long-range interceptors, like the prized SM-6, at just 150 to 200 missiles. 200 missiles. That is the entire defensive magazine standing between a $13 billion supercarrier and the bottom of the ocean. And those interceptors come at a staggering premium. The Navy's flagship SM-6 costs roughly $4.3 million per round. If a single Arleigh Burke fires a full broadside from all 96 cells, that destroyer just burned through over $400 million in firepower. If the entire strike group expends its interceptor inventory, you have vaporized more than $2 billion in a single, desperate engagement. Now, compare that finite magazine to the threat waiting across the Pacific. In 2020, the People's Liberation Army Navy commissioned its first Type 055 Renhai-class cruiser. Each of these massive warships carries 112 VLS cells. China already has 8 in the water, with at least 8 more under construction. Combine those with their fleet of 25 Type 052D destroyers, each packing 64 cells, and the math becomes chilling. The PLAN's total VLS count by hull already exceeds the surface combatant VLS capacity of the entire U.S. Pacific Fleet. And that is just the surface threat. That doesn't account for the land-based DF-21D and DF-26 carrier-killer ballistic missiles lined up along the Chinese coast. It doesn't account for the H-6 bombers carrying supersonic anti-ship cruise missiles, or the silent fleet of conventional submarines waiting in the choke points. For 40 years, the United States Navy operated under a comfortable assumption. No peer competitor could ever match American magazine depth. That assumption is dead. The arithmetic killed it. The question is no longer if an American fleet can be overwhelmed. The question is operational. How does an attacker actually drain those 200 interceptors? And what does it cost them to do it? Chapter 2. How the shield runs dry. 200 interceptors looks like a lot. The doctrine that fires them turns it into 100. Aegis, the combat system on every American destroyer and cruiser, follows a rule called shoot, shoot, look. To guarantee a kill against a fast or maneuvering threat, Aegis fires 2 interceptors at each incoming target. Then it assesses. If the threat is still flying, it fires again. That doctrine is not stupid. Against a small number of high-end threats, double tap saves ships. Against a saturation attack, it is suicidal arithmetic. 200 missiles becomes 100 kills. That is the entire defensive ceiling of the formation. The attacker's job is to put more than 100 credible threats over the strike group inside the engagement window. The cheapest way to do that is a layered saturation strike. Start with one-way attack drones, slow, low, and cheap. The Iranian Shahed 136, the platform the Houthis have been firing at American warships since 2023, costs between $20,000 and $50,000 per round. Layer in subsonic anti-ship cruise missiles flying low to the water. China's YJ-18 runs around $2.5 million per round. Russia's Caliber, roughly $1 to $2 million. Cap the wave with a smaller number of high-end weapons, supersonic anti-ship cruise missiles, hypersonic glide vehicles, or anti-ship ballistic missiles. A representative saturation package designed to defeat a U.S. carrier strike group might look like this: 100 attack drones, 40 cruise missiles, 10 ballistic missiles. Total attacker cost using open source pricing, roughly $250 million. Defender cost to engage every threat under shoot, shoot, look, approximately $2 billion in interceptors. The exchange ratio is 8 to 1 in the attacker's favor, and the attacker can produce replacements faster than the defender can. The United States manufactures approximately 125 SM-6 interceptors per year. Chinese annual missile production figures are classified, but recent RAND and CSIS analyses estimate Chinese solid rocket motor production capacity at several times the American level. At this point, any viewer who has watched footage of a carrier launching aircraft is going to ask the obvious question: what about the fighters? A Ford-class supercarrier carries 44 Super Hornets and a growing fleet of F-35Cs armed with AIM-120 AMRAAMs and AIM-9 Sidewinders. They are among the most capable air-to-air platforms in the world. Why don't they shoot down the drones and cruise missiles before the swarm ever reaches the destroyer screen? The honest answer is the second buried problem of modern carrier warfare, and it has 4 parts. Part 1. Numbers. A Super Hornet on combat air patrol carries 6 to 8 AIM-120s. The carrier can sustain roughly 6 to 8 fighters on continuous airborne patrol, plus another flight on 5-minute alert on the deck. At best, that puts about 50 AMRAAMs in the sky at any given moment. Reload, refuel, and rotate takes 45 to 60 minutes per cycle. The air wing can engage perhaps 80 to 100 targets in the first hour. It is additive to the surface combatant magazines, not a replacement for them. Part 2. Fuel. The Super Hornet was designed in the 1990s on the assumption that the carrier would always operate a dedicated tanker aircraft. That tanker, the S-3 Viking, was retired in 2009. For the past 15 years, the Navy has used Super Hornets themselves as buddy tankers, burning their own fuel to refuel other Super Hornets. The replacement, the MQ-25 Stingray unmanned tanker, has flown developmental flights, but is not yet operationally deployed at scale. By Navy estimates, current carrier air wings spend nearly 40% of their sortie generation just refueling other fighters. Combat air patrol is fuel-limited, range-limited, and turnaround-limited. Part 3. The threat itself. Modern saturation attacks are layered with decoys, electronic warfare drones, and feints. A flight of fighters chasing one swarm cannot intercept a real strike coming from another vector. The E-2D Hawkeye early warning aircraft can detect threats out to 300 miles. There are typically 2 airborne at a time. They cannot be everywhere. Part 4. And this is the wall. Fighters cannot engage ballistic missiles. The DF-21D and DF-26 fly at altitudes and speeds no manned aircraft can reach. The AMRAAM was built to chase fighters, not warheads falling from the edge of space. So the air wing helps at the margin. It extends the engagement envelope. It picks off the easier targets, but it does not, cannot, and will not replace the destroyer's VLS cells. The interceptor count on the surface combatants is still the binding constraint, and every fighter the carrier launches for defense is a fighter that is not striking the enemy's fleet, the enemy's air bases, or the enemy's missile launchers ashore. Carrier-based aviation is fundamentally an offensive instrument. Using it defensively forfeits the reason you brought it. None of this is theoretical. The Red Sea has been a live-fire laboratory for saturation warfare against the U.S. Navy since October 2023. USS Carney, USS Gravely, USS Mason, USS Laboon, USS Eisenhower, and the Eisenhower Air Wing have all been engaged in continuous defensive operations against Houthi drones and anti-ship cruise missiles for more than a year. By Pentagon acknowledgement, U.S. warships have fired hundreds of SM-2 and SM-6 interceptors in this campaign. At least one destroyer was forced to return to port mid-deployment for rearmament. Senior Navy officials told Politico in 2024 that the United States is, in their words, expending munitions at a rate that exceeds production. A Wall Street Journal investigation the same year reported that interceptor stockpiles had dropped to levels that worried Indo-Pacific planners. And that is against the Houthis, a non-state actor operating Iranian export-grade weapons from a country with no industrial base. Extrapolate that against an adversary with industrial scale, satellite reconnaissance, hypersonic weapons, and a 1,000-mile home field advantage. That extrapolation is what keeps Pacific Fleet planners awake at night, and it leads directly to the single word that Navy doctrine uses for the moment the cells go to zero: Winchester. Chapter 3. Winchester, when the fleet goes empty. Winchester is military aviation slang for out of weapons. On a destroyer, the call is made when the VLS magazine reaches 0 usable interceptors. The moment Winchester is transmitted across the tactical net, the entire strike group changes posture. The outer air defense screen, the bubble of denied airspace that extended hundreds of miles in every direction, collapses inward. The carrier transitions from offensive operations to survival mode. The captain orders maximum speed and aggressive maneuvering. The crew sets condition zebra. Every watertight hatch closed and dogged. Every compartment sealed against blast and flooding. With long-range interceptors gone, the strike group falls back on soft kill. The Surface Electronic Warfare Improvement Program, SEWIP, dumps maximum power into jamming hostile radar seekers. Nulka active decoys launch overhead, broadcasting false ship-sized radar returns to lure incoming missiles away from the hull. Chaff rockets paint the sky with metallic scatter. The ship is being electronically masked. Soft kill is never 100%. Whatever leaks through arrives at the inner defense layer, the close-in weapon system. The Phalanx close-in weapon system has been the Navy's last-ditch defense since 1980. It is a self-contained, radar-directed 20mm Gatling cannon firing tungsten penetrators at 4,500 rounds per minute. It has shot down inbound cruise missiles in live engagements. It is a remarkable piece of engineering. But the magazine holds 1,550 rounds. At full fire rate, that is 20 seconds of continuous defense. 20 seconds. Then it stops. Reload requires a team of ordnancemen to manually refill the magazine on the weather deck, exposed to the same threat environment, taking 20 to 30 minutes under ideal conditions. A saturation attack does not offer that window. But the real problem with Phalanx is not the magazine size. It is what Phalanx cannot engage at all. Anti-ship ballistic missiles, the Chinese DF-21D and DF-26, fly arcing trajectories that carry them to the edge of space and back down. Terminal velocity at impact, Mach 6 to Mach 10. A re-entry vehicle traveling at Mach 10 covers nearly 2 miles per second. No human can see it coming. No human can react. And there is a deeper physics problem. At those speeds, atmospheric friction heats the warhead surface to thousands of degrees. The air around it ionizes. The warhead becomes wrapped in a plasma sheath, a glowing envelope of charged particles. This is the same physics that creates the radio blackout for returning space capsules. Plasma sheath does 2 things to a defender. It scatters and absorbs radar energy, blinding the Phalanx targeting radar. And it scatters laser energy, defeating directed energy weapons before the beam can reach the warhead's metal skin. Even if Phalanx could see a Mach 10 re-entry vehicle and put rounds into it, the kinetic energy of the warhead alone is enough to destroy the target ship. Several thousand pounds of metal moving at Mach 6 does not need an explosive payload. The impact alone is equivalent to a small tactical strike. The Pentagon calls this a kinetic kill. The target calls it the end of the ship. A direct anti-ship ballistic missile hit on a Ford-class flight deck would penetrate the armored deck plating, the hangar bay, the avionics shops, the magazine spaces, and possibly the reactor compartment. Loss of the ship, loss of the air wing, loss of 5,000 American sailors. That kind of attack would also start World War III. This is where the strategic logic of the entire problem becomes important. The People's Liberation Army planners running their own war games understand exactly what sinking a U.S. supercarrier would trigger. They are not certain they want to trigger it. They want something cheaper, cleaner, politically deniable. They want to defeat the strike group without putting a mushroom cloud on television. They want mission kill. Mission kill is one of the oldest concepts in naval warfare. You do not need to destroy a warship to take it out of the war. You only need to make it unable to fight. A carrier strike group with empty VLS magazines is, for every operational purpose, mission killed. Its escorts cannot defend it. It cannot operate within range of land-based anti-ship threats. It has no choice but to retire from the theater. The carrier remains afloat. The sailors live. No nuclear-tipped political response is triggered, and a window of weeks, possibly a full month, opens during which there is no American naval presence in the contested area. A month is enough time to take Taiwan. It is enough time to consolidate the South China Sea. It is enough time, in diplomatic language, to create a fait accompli. The magazine depth problem is therefore not a tactical issue. It is a strategic one. The decisive variable in a Pacific war may not be the size of the explosions. It may be the speed at which a strike group can reload, which is the next question. Chapter 4. The Reload Problem. America has the greatest naval logistics force in human history. Why can't we just send out a supply ship and reload? The answer is one of the bitter secrets of modern naval engineering. Underway replenishment, what the Navy calls UNREP, is a U.S. specialty. Military Sea Lift Command operates a fleet of high-speed combat logistics ships. The premier vessels are the supply-class Fast Combat Support Ships, TAOE, capable of sustaining 30 knots, fast enough to keep up with a nuclear-powered carrier at speed. When a carrier needs fuel, food, bombs, or aviation parts, a supply class steams to the strike group and conducts UNREP at sea. Fuel hoses are rigged between the two hulls. Pallets transfer by highline. Helicopters lift 1.5-ton loads by vertical replenishment, VERTREP, every 2 minutes. Inside the carrier's magazines, the ordnance handlers, the red shirts, assemble bombs and fuse them for the air wing. On older Nimitz-class carriers, moving thousands of tons of ordnance from the magazines up to the flight deck was a choke point. The bombs traveled by cable-driven elevators. On the Ford class, the Navy fielded the Advanced Weapons Elevator. The AWE replaces steel cables with electromagnetic linear induction, the same fundamental physics as a Japanese maglev train. It moves up to 12 tons of ordnance at 150 feet per minute, roughly 50% faster than the Nimitz equivalent. 11 of these are built into USS Gerald R. Ford. They were so technically complex that they delayed the ship's full operational deployment by years. So, if America has maglev elevators, high-speed supply ships, and helicopter delivery, why can't we reload a destroyer's VLS cells at sea? This is the punchline. The AWE, the VERTREP, the red shirts, the entire underway replenishment infrastructure, all of it exists to feed the carrier's aircraft. Aviation fuel, bombs, JDAM kits, air-to-air missiles, air-launched cruise missiles. None of it touches the vertical launch system on the Escorts. For the VLS cells on Arleigh Burke and Ticonderoga-class ships, the operational at-sea reload capability has been, until very recently, zero. The Navy actually tried in the 1990s. The original Mark 41 VLS was designed with a built-in strike-down crane intended to allow at-sea reloading. The crane was tested and abandoned. The reason was physics. A standard missile is over 20 feet long and weighs roughly 1,500 pounds. It contains millimeter precision electronics and a delicate guidance section. To reload, you must lift that missile vertically from the deck of a swaying supply ship across a 30-foot gap and lower it through a cell opening with perhaps 2 inches of clearance on each side. In Sea State 3, with 5-foot swells, the deck moves enough that even a glancing impact on the cell wall would crumple the missile and turn a $4 million interceptor into scrap. The Navy concluded the risk was unacceptable and removed the crane from operational service in the early 2000s. The cells where the crane used to live are now used to carry more missiles. The doctrinal answer for the past 2 decades has been simple. When the magazines are empty, sail home. Sail to Guam, sail to Yokosuka, sail to Pearl Harbor or San Diego. Pier alongside, where a stationary crane and a calm harbor can do the reload safely. Then sail back. Round trip time from a contested forward position to a deep water port and back to station, 3 to 4 weeks, minimum. In January 2023, the Center for Strategic and International Studies, a Washington think tank whose war game work the Pentagon studies carefully, published a report by Mark Cancian titled "Empty Bins in a Wartime Environment." The conclusion: in a high-intensity conflict in the Indo-Pacific, the United States would expend approximately 50% of its long-range precision-guided munitions inventory within the first 3 weeks. Certain weapon categories would deplete in under a week. 3 weeks. The same window required for an American strike group to go home, reload, and return. The attacker does not have to sink anything. The attacker only has to wait. This is the magazine depth crisis. It is what keeps Pacific Fleet admirals awake at night. And until 2024, the Pentagon had no operational answer. Now, possibly, it does. Chapter 5. TRAM, the Navy's Last Bet. The program is called TRAM, Transferable Reload at Sea Method. TRAM is not a crane. The Navy already learned that cranes do not work at sea. TRAM is a modular, portable structure that mounts temporarily to a destroyer's deck, adjacent to the VLS launcher. It uses a guide rail system and a hydraulic stabilization gimbal. When a missile canister transfers across from the supply ship, the gimbal calculates the destroyer's roll in real time and counter-rotates the missile to keep it precisely aligned with the cell opening. The missile, in effect, ignores the sea state. It floats down into the launcher on a stabilized platform. In October 2024, the Navy successfully demonstrated TRAM at sea for the first time aboard the cruiser USS Chosin off the coast of San Diego. The system reloaded VLS cells while the ship was underway in moderate sea conditions. Secretary of the Navy Carlos Del Toro called it a breakthrough capability that, in his words, would convert returning to port from a requirement into a choice. What Del Toro did not emphasize at the press conference is that TRAM is not designed only for defensive interceptors. It is designed to reload offensive hypersonic weapons too, the conventional prompt strike system and the Blackbeard missile in the Flash program. If TRAM works at scale, it does not merely close a defensive vulnerability, it transforms American naval power. A U.S. surface combatant could fight, expend its weapons, and reload repeatedly without ever returning to port. The second piece of the Pentagon's bet is directed energy weapons. Helios, high-energy laser with integrated optical dazzler and surveillance, was built by Lockheed Martin and installed aboard the destroyer USS Preble in 2022. Helios attacks the cost asymmetry problem directly. The laser has a functionally infinite magazine. Each shot costs roughly $1 in diesel fuel for the generator. Against $20,000 drones, the math finally cuts in the defender's favor. But neither system is a complete solution. TRAM still requires 2 large ships to steam in close parallel at reduced speed for hours in waters that may be patrolled by enemy submarines. A modern Chinese Yuan-class submarine carrying YJ-18 anti-ship cruise missiles can engage from 100 miles. 2 slow, parallel, predictable ships during a reload cycle is the ideal target for a wake-homing torpedo or an inbound cruise missile. Helios performs well against drones in clear weather. It performs poorly in fog, heavy rain, or dense sea spray, exactly the conditions the Western Pacific specializes in. And it is functionally useless against anti-ship ballistic missiles. The plasma sheath that blinds phalanx also scatters the laser beam. The same physics that defeats the radar saves the warhead from the laser. And TRAM has not been tested under fire. A successful demonstration in calm water off San Diego is not the same as performing the maneuver in Sea State 4 with a hostile submarine somewhere in the area, drones still inbound, and the supply ship's captain uncertain whether the next contact on radar belongs to the People's Liberation Army Navy. The Pentagon is betting. The bet may pay off, it may not. What is no longer in dispute is the underlying truth that motivates the bet. The era when great powers could simply count carriers to claim the oceans is over. The winner of the next high-end naval war will not be the side with the biggest ship or the loudest explosion. It will be the side with the deepest magazine, the most resilient supply chain, and the fastest reload cycle. The Ford-class supercarrier remains a marvel, the inheritor of Midway and Leyte Gulf, an icon of American strategic reach. But as long as her survival depends on a finite number of VLS cells in the magazines of 3 or 4 Escorts, the ghost of the empty cell will haunt every American admiral who sails into the Western Pacific. When the alarms go off and the radar fills with red, the survival of a 100,000-ton ship and 5,000 Americans aboard her will not be determined by the size of the explosions on television. It will be determined by a single number on a console. That number is the count of missiles remaining, and the arithmetic does not lie. The question this leaves us with is not whether the U.S. Navy will solve the magazine problem. It is whether the Navy will solve it before the next major conflict forces the issue. If an American carrier strike group went Winchester somewhere west of Taiwan tomorrow, with the Chinese mainland to the north and the Philippine Sea to the rear, what should the strike group commander do? Run for Yokosuka and lose 3 weeks? Stand and gamble that TRAM works under fire? Disperse the formation and pray? Drop your answer in the comments. We read them. Subscribe for more analysis like this one and turn on notifications so you don't miss the next chapter. The future of naval warfare is being written right now. We will be here to break it down. We'll see you in the next briefing.